All right, this is our vocabulary for Module 2A. So we're going to go through the definitions together, and then we're going to make examples in class together. So a linear relationship is a continuous arithmetic relationship. What's really important, how you know something's a linear relationship, is we have straight line graphs. And again, we're going to do a couple of examples together in class after the video. Next up, we have exponential relationships. So this is a continuous geometric relationship. And another way to know if something's exponential is by looking at the graph. These have curved line graphs. Now, what does this continuous mean? Well, we're going to talk about that because there's continuous and then there's also discrete. So let's start with discrete. So discrete data is countable, and with discrete, the change happens all at once. And another thing is there is no data in between the points. And one other thing is there's unconnected dots on the graph, okay? I know I have it here, but you should also have it here. Okay, next up we have a continuous. So continuous data is measurable, all right? And that changes happen over time, and there is data between the points or the time. So this is where we have connected dots on the graph, okay? Okay, let's flip over to the back side and we're gonna talk about domain. Okay, so domain is where we'd identify the x's of a graph. So this is all values, okay? And remember, for a graph, you have to go from left to right, okay? And we're gonna write out how to write those in these two examples here. Okay, the next thing we're gonna be talking about is slope. So slope is another name for a common difference, okay? Which we've been dealing with. This module is very much a repeat of last module, but now we're giving everything a lot of new names. So on a graph, okay, you have to identify if it's going up or down for the top part of a fraction, because slope is a fraction, or if it's going right or left, okay? Now, if something's going up, that's a positive thing. If something's going to the right, that's a positive thing. If something's going down on the graph, that's a negative thing. And if something's going left on a graph, that's also a negative thing. You gotta think about Beyonce's song where she throws everything to the left. To find slope on a table, we put the y's math on the top and the x's math on the bottom. And when I say math, it's either adding or subtracting only. So let's put a little star here and make sure you yell that only at yourself. It's only adding or subtracting, that's what slope is. Because again, it's a common difference thing. Common difference is we only add or subtract. Okay, now in an equation, y equals mx plus b, our slope is always going to be attached to the x. It's always going to be that number in front every single time. Now before we were writing it towards the back, but now when we rewrite stuff, we're going to be writing the slope or the common difference with the x to the front side, okay? Okay, let's look at the y-intercept. So the y-intercept is another name for our start number, all right? Now, to find a y-intercept on a graph, it's on the y-axis. And remember, the y-axis is the bold line on a graph that goes up and down. It even has like a y next to it. All right, now let's look at a table. So on a table, it's with times 0 or when x equals 0. So like right here, 0 is our x number, right? Because it's underneath the x. So this 5 is my y-intercept. And then in an equation, it's y equals mx plus b. This b is our y-intercept. Again, it's going to be the number that's alone. Slope-intercept form is exactly like writing an explicit arithmetic equation at time 0, because look at our x. Our x is by itself. It's just an x. There's nothing else with it. So that's how you know you have a slope-intercept form. It also means time 0, and that's what that's what this y-intercept is happening at. So slope-intercept form is the slope and the y-intercept. So that's why it's y equals mx plus b with no parentheses around the x, because it's starting at time 0, which is where we find y-intercepts with time 0. Yeah? Point slope form, please change that to PSF, is exactly like writing explicit arithmetic equations at any time but 0. Okay? So if it's -1 or negative 100 million or 100 million, that's fine. That's point slope form. But if it's at time 0, that's slope intercept form. So point slope is anything, any number, but time 0. And we write this equation as y equals m times the quantity x minus our first x, okay? And there's gonna be a little love note, it's a little bit long. So with that x, just like before, we do the opposite when putting into the equation or out of the point slope form equation. Okay, there's gonna be more about this later, but this is very important. We always do the opposite. Think about this. Your first x probably might not have been the greatest. So do you wanna repeat that? No, you don't. You wanna do the opposite of that first x. Yeah? Pretty good. So we have y equals m times the quantity x minus our first x plus our first y, okay? And this one, you always want to do the same sign no matter what, right? So if it's positive, we'll write plus the number. If it's negative, we'll do minus the number. All right, so that's the end of this video. We are going to go ahead and do examples together.